Welcome to this post-launch Scrub News Conference here at NASA's Kennedy Space Center for the Space Shuttle Discovery's STS-128 mission to the International Space Station. Joining us here, we have two briefers who will give us the latest on launch preparations. First, we have the Space Shuttle Launch Integration Manager and the Chair of the Pre-Launch Mission Management Team, Mike Moses.
Good evening.
And to his left, we have the STS-128 Launch Director, Pete Nikolenko.
Good evening.
We'll start off with a status update and then open this up to questions. Mr. Moses?
Thanks, Howard. Let's see, folks. As we got into tanking, we ran across a failure signature today that really was one of those that's in our LCC, our launch commit criteria, that doesn't give us a lot of options. And we'll go through some of the technical details with that. But basically, it was a LH2, which is a liquid hydrogen inboard fill and drain valve. These are the big valves in the 8-inch line that feed the liquid hydrogen into, hence the fill, into the system. We basically fill the external tank up by flowing the propellant through the tail service mast, which is on the mobile launch platform. It goes then into the orbiter through the T0 umbilical, goes into the aft compartment where the main engines are, and then feeds up into the external tank to fill it. If we needed to drain the external tank, that's how we drain back out. And so really the plumbing system is the same system that we use to feed the propellants from the external tank down to the main engines. We just kind of tie in there to do fill and drain. So that's the part that we were talking about today. It's one of our big 8-inch line butterfly valves. And a butterfly is not really the right word because it doesn't look like a butterfly at all. But basically in that 8-inch duct, there's a valve flap. And the valve is really kind of complicated. And if you think about it, it's at cryogenic temperatures. It's liquid hydrogen and an 8-inch diameter pipe. It's a very big, complicated system. So there's a gear drive mechanism that makes this valve lift off a little cover and then rotate out of the way. It's kind of a visor-type valve. And we have to have good indications that valve's either open or closed. You want to make sure you know exactly where it is. You don't want an intermediate state. And so what happened, the failure that caused us to have a problem today, is when we went to close that valve after we were done with the fill, we did not get an indication that valve went closed. In the old days, we used to have some troubleshooting that would allow us to try to determine if it was an instrumentation failure, because there is a position indicator, that little limit switch that says, hey, when you've rotated far enough, it trips a little contact and says, I'm now in the closed position. That's what we're looking for. Well, that instrumentation can fail on you, especially at cryogenic temperatures. You're never sure exactly what's going on there. We don't have a big history of that, but that's one of the things we're worried about. But the LCC, based on some failures we had in history, back in 1993 we had a failure, and then during a little while later, one of OV-105's OMDP, we had a failure. And when they tore the valves apart, they found some galling, which is basically the metal getting spalled up as it rotated past some other metal, basically jamming. And you create some debris, and as this valve moves into that debris, it can actually break, and now that big flapper valve gets stuck and doesn't move anymore. And that's the thing we want to avoid. So the LCC is really set up to say you want to make sure that valve goes closed because it needs to be in a good closed position for launch. That's where you want it to be. But don't go cycling it around, because if it is broken or if it's about to break, you really need to make sure in a drain situation you can open that valve back up again. Otherwise, it's a very challenging job to drain the external tank in any appreciable amount of time. And that's really the condition, the hazard that we're trying to control. Not so much once you get in orbit, because there's two of these valves in series. If one of them failed to close, it's not that big a deal. There's another one right behind it. But in a drain situation, you need to make sure they can come back open again. So the LCC kind of says, before you go do any of that kind of cycling and testing, you need to go get back in ambient conditions. Don't do it with a load of cryo on board, because if it breaks while you're doing that, you could find yourself in a very bad place. So that really sets us up to say you got to go drain the system and get it down to ambient, which really drives us into a 48-hour scrub where we got to go let things boil off and get at a condition where we can then go do some testing. Now, along the way, we're going to get some indications as we move this valve. We really do think that this is just telemetry. This is a pneumatic operated valve, so we use helium pressure to push a piston to drive a gear to open this flapper back and forth. It's not an electrical operated valve. It's a hydraulic, or a pneumatic operated valve. And so we have the pressure traces. We know it looks like we see that the valve is going its full range of motion. But we have a much bigger database at ambient temperatures when we do valve checkouts on the ground pre-launch than we do here at cryo conditions. So we want to get back to that pre-launch state where we know it's an inert system, go run some valve cycle tests, compare those two sets of data, and show that we really do have just a position indicator problem, and the valve's truly working the way it is. Now that's postulating. That's where we want to go. The teams are going to spend the next 2 days gathering, first off, the technical analysis to say that if that truly is the condition, we're comfortable launching in that scenario, and then go gather the data to make sure it really matches with what we think. If we find that that's not the case and that data doesn't sync up with what we think we have, or that the team just doesn't get comfortable that we really can tell truly that this valve is actually open or actually closed without this position indicator, then we would probably not be in a position to launch 48 hours from now, and we'd be in a much longer turnaround where we go in and R&R either parts of that valve or all of that valve. But we went ahead and set ourselves up for success and say, let's go for a 48-hour scrub turnaround where we'd come back and get ready to start talking about launching on Thursday night, but the launch attempt is really on Friday morning. I think the window opens at 00:17 Friday morning. So we'd come back in on Thursday about 2 o'clock in the afternoon to talk tanking weather, and then get into tanking and come in. And so we set a mission management team meeting a couple hours in front of that at noon on Thursday to basically go review the data, see that it syncs with what we think it does, and go forward. And again, that's our success-oriented plan. Between now and then, we'll learn a lot more. Tomorrow night, Pete will go into the schedule a little more, but basically around this time tomorrow night, we should start to get some of that data in-house, and we'll see if we really do have what we think we have. In addition to that, when we were draining the tank, we ran into another problem, which kind of takes us to the same path of we need to go inert the system in the tail service mast. I'll let Pete tell you the details about that signature. But basically, we kind of talked about it. Had we had a weather problem today, we were going to head to a 48-hour turnaround. You know, our pre-planned, briefed to you long ago, was a 2 launch attempts, stand down for 48, come back for 2 more, stand down for 48, come back for 1 more, and then we'd be done on the range. So that takes us to our last launch attempt on the 30th. We're kind of still in that same posture. We're gonna proceed down that path. So we're gonna have our next launch attempt on Friday, and it's actually funny. Friday we're gonna have 2 launch attempts. We'll have one very early in the morning Friday, and then we'll have one very late at night Friday. It's really 23 hours and 40 minutes later, so it's a day in our book, but it happens to be on the same calendar day. So that would be our next 2 launch attempts. We'd stand down for another 48, bring in some more tankers to reload the cryospheres, and be ready to have 1 more attempt before we lost the range. We talked a little bit about the weather. There's a weak wave in the tropics off of Puerto Rico that the team is looking at. The Hurricane Center's off, flying some aircraft through it, trying to get a feel for it. That played into our decision-making just a little bit today to see if we thought we could try again tomorrow. It became technically very apparent very quickly that we would not be ready to have a discussion tomorrow, and these 2 scenarios really drove us to needing the system safed and inerted before we could even talk about our posture to launch again. So now we have some more time to talk about that wave and what it's going to do. So the weather might choose to say that Thursday's maybe not the best time, Friday morning is not the best time to try a launch attempt, but we got a little bit of time to go look and evaluate the weather conditions we have. So that kind of played into our thinking tonight as well. I think with that, I'll let Pete talk about some more of the technical details, and then we can fill in some more holes and get to the questions.